welcome back to another daring episode of Beau Maths. In the last video, we talked about percentages and how we can kind of look at them in the context of all the fraction stuff that we've been doing. And today we're going to get some practice with that. Normally we do around 5 questions, but today I have 7 just because I think the questions are going to be a little bit shorter. So, as always, try them out for yourself before we get started, and then without further ado, let's get going. Question 1 says, convert the following percentages into decimals. So the first one we have is 74%. And if you recall, the percent just means we're dividing by 100, right? Percent, per 100. And doing so, that takes this and puts in the form of a ratio. But to make that into a decimal, right? Dividing by 100 is just taking our decimal at the end of 74, right? We can imagine 74 is just 74.0. And sliding the decimal 2 places to the left, and what we end up getting is 0.74. So this is the decimal that represents the percentage. We can do the same thing with 12.324%. All we're doing is we're taking 12.324 and we're dividing it by 100, which is going to take this decimal right there and move it 2 to the left, which gives us 0.12324. So this is the decimal that represents that percentage. And lastly, we also talked about how we could have percentages that exceeded 100. So in this case, we have 567%. So if we do 567 divided by 100, we're going to take the decimal at the end, slide it over 2 to the left, and we get 5.67. So notice in this case, we get a decimal that's bigger than 1, and that's because we're working with a percentage that's bigger than 100%. All right, so that's not too bad. It's a pretty straightforward conversion. But if you need some extra practice, choose any percent you want, right? I just picked a random number, put a percent after it, and then convert it into a decimal. Let's go on to question 2. Question 2 says, convert the following percentages into fractions. So the first one we have is 50%. And to make it into a fraction, just like what we did in question 1, we're going to put it out of 100, right? Dividing by 100 is also a fraction with a denominator of 100, but now we're just going to go a different route, whereas up here we made it into a decimal by doing the division by 100. Over here we're just going to convert it into an equivalent fraction. We're basically going to simplify this fraction. And 50 over 100, well, both can be divided by 50. And what we end up getting is a half. So a half is basically the smallest fraction or the most simplified fraction that represents 50%. We could do 106%. So same kind of deal, 106 over 100, right? We always do that with percentage. But now we can simplify this. Well, these are both divisible by 2, right? They're both even numbers. So if I divide them by 2, I'm going to get 53 over 50. And this numerator and denominator are co-prime with each other, which means this is a simplified fraction. So this is the simplest fraction that represents 106%. And for the last one, we have 0%. Now 0% is maybe a little more interesting because our numerator is going to be 0. And any fraction with a numerator of 0, well, that is just 0, right? 0 divided by 100 is 0. So we don't really express this as a fraction because we just end up getting a 0 that doesn't have any decimals or anything, right? So we can just leave this as the straight number there without any fractions involved. And for extra practice, choose any percent that you want and convert it into a fraction. First make it out of 100 and then simplify it. Let's move on to that third question. All right, question 3 says, convert the following decimals or fractions into percentage. So before we were starting with a percent and then converting it into a decimal or a fraction, but now we're going the other way around, where we start with either a decimal or a fraction and we convert it into a percent. So let's start with 4/5. All right, so one thing we can do for this is if we just make this into an equivalent fraction out of 100, the numerator is going to be our percent, right? Because we saw that going from percents to fractions, the numerator was always kind of what the percent was, right? 50% was 50. 106% had 106 in the numerator, and so on and so forth. So if we can make this into an equivalent fraction out of 100, we'll be good to go. And we can do that because we know that 5 times 20 is 100. So just doing that to the numerator as well, to keep it equivalent, we're going to get 80 out of 100, which means that this is then 80%. All right, good stuff. Next one we have is 2/9. Now, 2/9 can't go into 100, not evenly anyways, right? We know that 9 times 11 is 99, and then if we add another 9 to get to the next multiple, we pass 100, right? So 9 will not go into 100 very nicely, so what we're going to have to do instead is we're going to first convert this into a decimal, and then take that decimal and convert it into a percent. So we will start with doing the long division of 2/9. So what we get is 2/9 is just 0.222 repeating. But what's nice about this is now we have a decimal, right? So converting this into a percentage, we just multiply by 100%. And remember, 100% is just 1, right? So multiplying by 1 doesn't do anything, right? So we're allowed to do this and it will stay equal with itself. So if we multiply by 100%, that's just going to slide this decimal back to the right by 2. So what we're going to get is 22.2 repeating percent. So this is the percent that represents the fraction 2/9, or the proportion of 2/9. All right, let's go on to these two. These ones should actually be easier now because we're already starting with a decimal. We don't even have to do any conversions from the fraction into a decimal. So if we take 0.5, all we have to do is we take the 0.5 and we multiply it by 100%, which is going to take this decimal and slide it 2 to the right. And we can just imagine there's a bunch of zeros after this 5. So if we slide it 2 to the right, we're going to get 50%. So 50% is 0.5, which should make sense because we also saw that 50% was a half, and we know that 1 over 2 is the same as 0.5. That's a pretty common fraction decimal conversion. So we are going to get 50% here. And for 1.00009, well, this is over 1, so we're probably going to expect a percentage that exceeds 100%. So when we take 1.00009 and multiply it by 100%, we're just taking this decimal, sliding it over twice, and we're going to get 100.009%. So very, very slightly above 100%, but nonetheless it is. Okay, so that is question 3. And for extra practice, choose any fraction or decimal that you want and try and convert it into a percent, just like we've done here. Let's move on to question 4. If a bag of milk costs $6 before tax and tax is 15%, what's the total price? So some of you might be wondering why a bag of milk. In some places in Canada, bagged milk is a thing. And maybe other parts of the world, but I'm from Canada, so I know that for sure at least. So this is an example of using percentages with taxes, with real life stuff, right? This was a big motivation for why we even wanted to study percentage because, well, they're all over the place, right? So if we take $6 and we apply the 15%, what we're doing is we're doing 15% and we're multiplying it by the $6. And this is going to basically tell us what piece of the $6 we're going to add on top, right, to that, and that's going to go to the government or whatever. So 15%, first of all, we need to convert that into a fraction or a decimal. I'm going to go with a decimal just because it's a little easier. So that's going to be 0.15, and then we multiply it by the $6. Okay, so when we multiply 0.15 by 6, we are going to get 0.9, which is the same thing as 90 cents, right? So that means our total then is going to be the $6 that we have to pay for the milk, plus that tax that we just calculated of 90 cents. So our total is going to be $6.90. And for extra practice, apply different tax percentages to different priced items to find their total price. You could even go out to the store and, buy something, figure out what the percent is in your area, and then apply the percentage to the thing and see if you actually got the right price before you go to the cashier and they just use the computer to calculate it. So you could have some fun with that. But let's move on to question 5. So I think this one's going to be a little bit trickier. If a bag of milk costs $6 before tax and $6.06 after tax, then what was the tax rate? So we know that the total, that's going to be basically the price plus the tax, right? We just did this in question 4. And we know our total is $6.06, right? So we know that $6.06 is going to be equal to our price, which is $6, and then we're adding our tax, right? But we know that to get from $6 to $6.06, that means that our tax is going to have to basically be that 6 cents, right? So we have 6 cents worth of tax. So now what we need to do is we know that the tax was basically, that's equivalent to basically taking some percent, we don't know what it is yet, of the $6, right? The tax is determined as some piece of the $6. So we need to figure out what percent of $6 gives us this 0.06. But here we have a 6, and we started with $6, right? So it's not too difficult to see kind of what fraction will convert us over, right? We've essentially just taken the decimal after 6, and we've moved it 2 to the left, and that produced 0.06, right? So to go from $6 to 6 cents, we've essentially just moved the decimal over twice, which is basically multiplying by 0.01, right? If we do $6 and we multiply by 0.01, that's going to be 0.06, right? And that's exactly how much this tax is. The 0.01 written as a percent, well, if we write that as a percentage, we're just sliding the decimal back 2 places and we get 1%. So that means our tax here must have been 1%. All right, so again, that was a little bit trickier, but all we did is we noted that, okay, to get from $6 to $6.06 after tax, the tax must have been 6 cents. And since the 6 cents is calculated as some percentage of the cost before the tax, then we knew that we would have to basically convert this 6 into 0.06, which we can do by multiplying by 0.01, which is the same as 1%. So that's how we determined that the tax rate must have been 1%, which is a very low tax rate. All right, let's move on to question 6. Kieran got 3 marks out of 1,000 on the big boy certification test. What percent did he get? So this one shouldn't be too bad, because all we have to do is we take the 3, which is what he scored, out of the total of 1,000. So he really bombed this this test. He is not a big boy certified, that is for sure. So if we do 3 over 1,000, we want to convert this into a percent. There's a couple things we could do. One thing that we could do is we could note that to get from 1,000 to 100, we could just divide by 10, right? We know that 1,000 divided by 10 is 100. So then doing that to the top to keep this as an equivalent fraction, we get 3 divided by 10, which is 0.3, right? We're just sliding the decimal to the left by 1, over 100. And since this is now a fraction out of 100, we know that the percent is just going to be the numerator. So this is 0.3%. So we got 0.3% on the test. If you wanted to do this a different way, where we did 3 divided by 1,000, right? A fraction is still division. Then what we could do is take 3 divided by 1,000, and dividing by 1,000 would slide our decimal over 3 places. So we would get 0.003, right? The decimal was slid over 3 different times. And then converting this into a percent, we would multiply it by 100%, which is going to slide the decimal back 2 more places, which is then going to take us to 0.3%. So either way, we get 0.3%. So it doesn't matter the way you calculate it, Kieran, you still horribly failed this test.
And not even half bad.
Gas prices went from $1.20 per liter to $1.45 per liter. What's the price's percent increase? Okay, so when it asks for the percent increase, it basically wants to know what the increase was like compared to what the original price was. Let's say my price went from $1 to $1.20. So that's a 20-cent increase, right? But if I went from, say, like $30 to $30.20, that's also a 20% increase, but that's a much smaller increase compared to the original price. If you're paying $30, it's not going to mean as much to add an extra 20 cents on top of it. But if you're paying $1, it means more to add an extra 20 cents on top of it, because that's a fair chunk more compared to the dollar that you originally were paying. Versus here, 20 cents is basically nothing compared to the $30. So the percent increase is going to basically capture this idea of how much did it increase with the context of how much you were originally paying, of the $1.20. So what we need to start with is figure out, okay, how much did it increase by? And we can calculate that by doing $1.45 minus $1.20, which is going to give us 25 cents. So it increased by 25 cents per liter. And now what we need to do is we need to take this increase and put it back into the context of comparing it to the $1.20. So we're going to take the 25 cents and divide it by the $1.20. And now we haven't fully talked about how to do decimals divided by decimals yet. Some of you may know it, some of you might not. There's a nice kind of fraction explanation here. We're going to go more in depth in a later video on it. So if you want, you can just use a calculator to figure this out for now. But you should also be able to understand this explanation. So if we do 0.25 divided by 1.2, I can multiply the numerator and denominator both by 100. And what that's going to do is essentially it's going to just eliminate all the decimals here, right? Because multiplying by 100 slides our decimal 2 to the right. So on top we're going to get 25, and down on the denominator we're going to get 120. And now we don't have any decimal to deal with. This is kind of a nice track with using equivalent fractions that produces a fraction that doesn't have any decimals inside of it. Okay, so now that we have that, we could simplify this a little bit. So they're both divisible by 5. So that's going to give us 5 over 24. And from here, we are going to have to calculate what the actual decimal is. So doing some long division. So doing the long division, we're going to get to 0.2083 repeating. So we get 0.2083 repeating, which then to make this into a percentage, we multiply it by 100%, which is going to slide this decimal over by 2, and we're going to get 20.83 repeating percent increase. So that means that the price increased by 20%, which is quite a lot actually. For a price increase, that's a substantial amount for a price to go up by. And for an extra example, let's say the gas price went from $30.20 to $30.45 per liter. Now, of course, we do not want that to happen because that is an insane amount. But let's say that was the case. So it's still a 25-cent increase, right? But now what we're going to be doing is we're going to be doing 25 cents over $30.20, right? So this is the increase amount over the original price. And what we're going to get is using that trick of multiplying by 100 just to get rid of these decimals. We're going to get 25 over 3020. And I'm just going to do that on my calculator. So if I do 25 divided by 3020, it just gives me a fraction, but I can use the S to D button to give me a decimal. We get 0.00828. I'm just going to round it off a little bit just because that's a very long, a very, very long decimal. So then converting this into a percent by multiplying by 100%, which will slide this decimal over twice, we're going to get 0.828% increase. So notice, adding 20 cents at this high of a price, that's an extremely small increase, right? Only 0.8%. But when your price is as low as like $1.20, adding that 25% increase is quite a lot, right? It's 20.83 repeating percent increase. That's going to do it for today's video. I hope you found this to be useful. I hope you're feeling more comfortable with percentages, with the conversions that come about with percentages, and some of the applications with it. There's going to be a couple more videos kind of focusing on percent, both with some applications, some cool mental math tricks, and yeah, so I hope you're looking forward to that. But until the next video, you have a good one, you stay groovy, and I'll see you then.
Beau Maths.